Okay, here's 7.4. This is your last section in Unit 7. Getting ready for that test coming up. Oh, yeah, I know we're excited for that. All right, this ain't going to be too bad, except for maybe the word problems, the applications, but the regular 90% getting your 90 on your power assignments, you should be okay. You shouldn't be that bad for those. First things first, logarithmic equations, that's what we're talking about here in 7.4. Just a couple things we need to know. One is properties of equality. Basically, it says if my bases are the same, okay, on either side of the equation, that means my exponents also have to be the same. Now, some of you might be like, well, that just makes sense, right? Why would they be different? If they're the same numbers, why would my x and y be different? Well, I'm just telling you we need to actually make sure that they're the same. So this is a property that some old dude probably, 400, 500, 600 years ago, he probably proved like in his basement of his mom's house. Okay. Second one, it says log base b of x equals log base b of y if and only if x equals y. Well, that's pretty self-explanatory. If there's a log of the same bases, then these numbers here have to be the same. They only work when b is greater than 0 and b is not equal to 1. The reason why it can't be less than 0 is because they can't be non-negative, and also can't equal to 1 because this would make it a lot easier. So because you would have an infinite amount of numbers that would make this sense. Okay, so we're not going to talk about that, but let's get into some equations here. These are going to be pretty simple, so just bear with me here, and we should be good to go. Okay, there's really three parts to this power assignment. This lesson, we have solve by equating exponents, the logarithm of each side, and then raising it to its base and stuff like that. And that's the third section there. So I'm going to do the first two in each, and you're going to do the third one. The third one's a little harder, but it's the same general concept. It's just taking it to that next level. So here we go. First one, I need to make sure these bases are the same. Well, one's a 7, one's a 49. Can I turn this 49 into a base with a 7? Well, yeah, I can, because it's 7 squared, right? That's what 49 is. So it's 7 squared raised to the 2x plus 1 power is equal to 7 to the 3x plus 4 power on the left-hand side. Well, if you recall from exponents back in Unit 6, I'm raising a power to a power, so I have to multiply those together. So it's really 7 to the 3x plus 4 equals 7 to the 4x plus 4. I'm sorry, 4x plus 2. 2 times 1 is 2. All right, now the formula, the property of equality that's said on the top, it said as long as these bases are the same, I can drop the exponents down, right? Drop them like they're hot. 3x plus 4 equals 4x plus 2, and now I can solve an equation. I'm going to minus the 3x over here. I'm going to minus the 2 over that way. So when I bring the 3x over, I get x. When I bring the 2 over, I get what? I get positive 2. So x is equal to positive 2. And if you want to, you can go back and check and put this into the original and see if both sides actually come out. I'm not saying you have to. I'm just saying you can if you want to. Number 2, I want to what? Get away. I want to get away. I wish I could go somewhere. I'm kind of broke. Number 2, I want to make these the same basis. So I know 25 here is 5 squared, and I know that's being raised to the 2x plus 3 power. So really, that's what? 5 to the 4x plus 6, because remember I had to distribute that through, equals. Well, is there any way that I can change this 1/5 into something with a base 5? Well, yeah, if you recall, negative exponents actually allow me to flip, right? They flip and take the reciprocal of both sides. So this -1 here is really then also raised to the 7x minus 1. When I distribute here, I get 5 to the negative 7x plus 1. Okay? Now, again, bases are the same. So I'm going to drop the exponents like they're hot, and I get 4x plus 6 equals negative 7x plus 1. I'm going to bring the negative 7x over. That gives me 11x. I'm going to bring the 6 over here. That gives me negative 5. Now I divide by 11 to both sides, and I get negative 5 over 11 is your answer for the variable x. Okay, that's number 2. Number 3, what I want you guys to do is to try to solve this one yourself. Hint here, make sure 16 and 64 are the same bases. Right now, I can't change them. I can change them. There's 2 different ways I can do this problem. So we'll talk about maybe both of those ways. But Pause the video now and try to do it. Okay, again, we said there was 2 ways to do it, all right? So first way, this is probably the faster of the ways. So 64 is really 4 to the 3rd power. Okay, it's 4 to the 3rd. Now, if you wanted to go one step further, you could say it's 2 to the 6th power, and then you can break down that way as well, and that's okay. So let's use 4 first, and we'll show you how they can get the same answer by using the 2. This 16 is really 4 to the -2 power, right? That negative flips it, and then I have negative 3m plus 1. You have to make sure you understand negative exponents. So if you don't, go back to 6-4. This is where we started talking about them for the first time this year. You've also should have known them probably from junior high, maybe algebra 1, okay? Negative exponents are going to be huge in this section. So again, I got to distribute. So that's 4 to the 6m minus 2 equals 4 to the 3. Then again, I can drop the exponents like they're hot. 6m minus 2 equals 3. Bring it over. 6m equals 5. M equals 5 over 6. Now, some of you might be thinking, well, that doesn't make any sense. I need, what happens if I got my 2 as my base, right, instead of using 4? Well, let's try that. So this we said was already 2 to the 6. Let's try now. 1 over 16 is really 2 to the -4 power. Then I'm being raised to the -3m plus 1. Again, I got to multiply. So it's really 2 to the 12m minus 4 equals 2 to the 6. Drop these down. 12m minus 4 equals 6. Bring that over. 12m equals 10. M equals 10/12, which is reduced to 5/6. Voila, we get the same answer. Well, guess what? Math should work that way. You can do it multiple ways. You still get the same answer. Okay, it's not made up. I didn't make up an answer. I explicitly showed you how we found it. All right, so that's solved by equating exponents. That's a pretty easy stuff right there. Let's go on to the next section there, logarithms of each side. Number 4, I want to find the answer. So the first thing I have to do down here and on the next section as well, I'm just getting so excited right now talking about logarithms. What I need to do is I need to isolate either I can't spell, either the logs or the base with an exponent. Okay, I need to isolate that. Means I need that by itself. Okay, so on this number 4 here, this base with the exponent of x is already by itself. So that's great. So I have 4 to the x equals 15. So that's really good right there. Now how do I solve it? Well, what I do is I know the base is 4. So what I'm going to do is I'm going to introduce a log base 4 to both sides. So log base 4 of 15, log base 4 of 4 to the x. So this is how I'm going to write it. Log base 4 of 4 to the x. This is my original expression equals log base 4 of 15. Again, the 15 is my original expression. Now here's where the awesome thing that occurs. Once I do both sides to that log base 4, and really you're going to, this number and this number are always going to match. Okay, they're always going to match. So what happens now, what's really cool, is log base 4 and that 4 are going to cancel. They're going to cancel out. And what happens? This x just drops. Oh, man. And then this right-hand side is really log base 4 of 15. But remember from the last section, log properties, this was the change of base formula. And what that means is I'm going to take x to be log base 10. Remember, I can change it to whatever base I want to. Log base 10 of 15. And I don't need to write the 10 there because it's base 10 over log base 10 of 4. And I'm going to put this into my calculator like that. Okay, log base 15 divided by log base 4. I'm going to make sure I have both of those put in. Make sure I put parentheses around the 15 and parentheses around the 4. Otherwise, you're going to get a wrong answer. Hit enter, and I get my answer as 1. So I'm going to put x is approximated as 1.953. 3 decimal places is what I want. 3 decimal places, please. In the word problems, we're going to go a little bit more than that. So in these ones here, 3 decimal places. All right. So there you go. X is approximated as 1.953. What that means is if I put 1.953 into this x down here, so 4 to this power is equal to 15. right? Because isn't 4 to the 2 equal to 16? And this is not quite 2. All right, just think about that's what logs mean, right? That's what exponents and all that stuff ties together. All right, let's go to number 5. Remember the first thing I said on this particular instance, I said I want to isolate for the log or for the base with the exponent. So the base is 10 with the exponent of 6x. So I'm going to divide both sides by that little 9 there. I get 10 to the 6x equals 5. Now I isolated it, so now I'm going to introduce a log. What's my base? Well, it's going to be base 10. But remember, I don't actually have to write it because log base 10 is understood. Okay, so I get log of 10 to the 6x equals log of 5. Remember, log base 10 of 10, those are the same bases, so they cancel. So the 6x is just going to be dropped. I don't have any room, so I can't drop it there, so I got to drop it like it's hot way up there. Equals log of 5. So then what am I going to do? I'm going to divide both sides by that 6. So let's pull up my calculator. So there we go right there, log of 5 divided by 6. Remember, the base on the calculator is already base 10, so I do not need to do change of base formulas or anything like that. Please make sure you use parentheses around that 5, otherwise it's going to calculate it incorrectly. Hit enter, and again, 3 decimal places is what I want. So x is approximated as 0.116. There we go there. All right, I want you guys to try number 6 there. That's number 6. That's not in the problem. The 5 is. And remember, I want to try to isolate this here because that's my base with the exponent. Bring possibly the 7, bring the 5 over, and then go from there. Okay, number 6 here. Remember, that's, again, not that. So I got to move the 7 first. Okay, I have the box around that. So I brought the 7 over, which is 80, right? Brought it over, it's an 80. Then I got to divide by that 5, which makes a 16, is equal to 14 to the 9n plus 8. Well, now I have my base and my exponent isolated, so I'm going to introduce log. Well, hopefully you introduce log base 14 to both sides, log base 14. Okay, so now let's rewrite this a little over here. I got log base 14 of 14 to the 9n plus 8 equals log base 14 of 16. Remember, my bases are the same, so they get to cancel. 9n plus 8 drops it like it's hot. Now I got to do change of base on the right-hand side. Change of base. Log of 16 over log of 14. And then what am I going to do? I'm going to do this. Then I'm going to minus 8 from it. And then what am I going to do with that? I'm going to divide all of this by 9. So let's do that in the calculator. So my answer, once I did it on my calculator, should be n is approximated. Now it's n, not x, okay, is negative 0.772. Now, if you forget how to do this on your calculator, okay, I kind of have it shown up here. You can see that I did log of 16 divided by log of 14 first. Then I got an answer, and I got that answer, and then I subtracted 8 from it. And then I got that answer, and then I divided it by 9. Now, I could have done it with one single line with a bunch of parentheses, but that might have confused you guys. But this is a clear and logical explanation. So step 1, step 2, and then step 3. Okay, that's how you work on logarithms on each side. That's the hardest they're going to get. All right, right there. If you have questions, again, please make sure you ask on the practice, not on the power assignment, on the practice. Let's go to the next section. Just like in the last section, okay, we want to isolate for either logs or for the base and the powers. Well, this one has logs, so I want to isolate for the logs. So this here is a log. I want to isolate. I want to bring that over. That gives me a 4 equals, and this is positive, log base 2 of b. Well, this is base 2. Remember in the last problems, I had a base of a number, and then I took the log and I made it a new base. Well, in this case, this is base 2, so I'm going to introduce a 2 to both sides. This is going to be my new base. This 2 and this 2 have to match, always. Now, what am I going to write? Well, I'm taking this 2, and I'm going to raise it to everything on either side. Okay, so this 4 goes over here. That's the new exponent. This log base 2 of b goes on this new exponent on that 2. Then this 2 log base 2 cancel out. the b drops, and then 2 to the 4th power is 16. And that's your answer for that one. Not too bad. Okay, not too bad. It looks a lot more complicated than it actually is. Number 8, I want to isolate for the log. Well, remember, this is a natural log, so just because it doesn't say log, it still is a natural log. This brings it over. That's a 9. I got ln of x minus 6 equals 9. Well, what am I going to introduce here? What's my base on the ln? Remember, it's an e. So I'm going to take an e and raise it to now both sides. So e to the ln of x minus 6 equals e to the 9. The e to the ln cancels. X minus 6 drops like it's hot. And then I take e to the 9th power. Then I got to move that over. So I'm going to add 6 to this. And I'm going to calculate it. So on your calculator, you got to find that e button. And that e button is the blue one right above the ln. Okay, you'll have to hit second and then ln, and it should give you the e. So e to the 9, and then close parentheses, and then plus 6. Enter, gives me 8,100. So x is approximated as 8,109.084. Remember, 3 decimal places. Okay, 3 decimal places, please. So there you go. That's how you do it with natural logs. What I want you guys to do is to try the last one there. Remember, isolate for the log. So I got to get rid of that 5 and that 7. And then solve it. See what you guys get. Hit pause now. All right, here we go. I got to bring that 5 over. That gives me a negative 7. Okay, then I got to divide by a negative 7. So that gives me a positive 1. So I have log base 3 of n minus 10 equals 1. Now this is the base 3, so I'm going to introduce a new base, which is, oh, it's 3. It's the same one. Oh my gosh. And then I'm going to take this to the 1st power. These cancel. N minus 10 comes down. 3 to the 1st power, guess what? That's 3. Add that over, n equals 13. That one wasn't even that hard. That one was pretty simple. All right. Basically, those 9 problems are your examples. That will give you a 90 on the power assignment. Okay, no doubt. No diggity, no doubt. All right, let's go on to one of the word problems to kind of introduce you to some of the applications for this section. This is on the next page. This is Newton's law of cooling. I don't know if you guys cover this in physics or not. I don't know what you guys do in Schlegel's class or wherever you have for physics, but here we go. So Newton's laws of cooling says T of T equals T sub S plus, and then in parentheses, T sub 0. You usually say this is like T sub naught minus T sub S, and then e to the negative kt. And each of these things, there's a whole lot of variables in there. They mean different things. This e is the only one that's really not written down because e stands for something. E is an actual number. Okay, so T of T is the temperature of the object after a certain time. If something's 100 degrees after 7 minutes, and that's kind of what we're going to be talking about there. T sub S is the temperature of the surrounding environment. You notice I underlined or boxed the S there because T sub S is surrounding. So that's like the room temperature. If your room is 107 degrees, right, because you're in like a hot yoga class or like something like that, or a sauna, then it's going to be a little bit different. T sub 0 or T sub naught is the initial temperature of the object. Okay, initial, this is what it starts at. K is the constant that changes depending on the material properties of the object. Okay, this is something that most of the time we're going to be given or have to find. And then the problems that we're going to be given, we're going to have to find it. I'm sorry to tell you. T is the amount of time in minutes. It's always in minutes that has passed since the object began cooling. Basically, what we're going to be doing here is if we took something, say, out of an oven and it's really, really hot, I want to find out how fast or how much time it takes for me to actually, say, have the ability to eat that without like burning my tongue or whatever. Some of you have probably done that before. Well, I mean, let's say with coffee or something like that. It's so hot that you have to wait to cool it down. Well, this is really the formula that goes into the cooling of that coffee. I know we're just putting ice in it or waiting, 10 minutes to drink it, but there's an actual formula. So now you can go home and be like, Mom, I can figure out how long it takes for that lasagna to come out of the oven because I like lasagna, but I hate Mondays. Hopefully you got that Garfield reference. Let's get into some examples. There's one example we're going to get into here and then in your application on your practice, you have another one. All right, so let's go. Okay, Mr. Brust, apparently you remember I said I took these problems from some school place in Germany, right? So this is one of the dudes. He loves his pizza. This should be changed to everyone loves their pizza. Okay, everyone. I don't know about you. I haven't met a guy that doesn't like pizza. And that's crazy if you don't like pizza. Unfortunately, every time he takes it out of the oven, he burns his tongue. Okay, and you guys can read the rest of it there, but there's a couple things that we need to understand. First off, we need that formula, right? That's probably the biggest thing that we're going to need. So I'm going to write that down at the bottom. So there's our formula. I know I was going to write it at the bottom, but I didn't. I kind of was like, I'll just write it right there. All right, so there's a couple things that we need to understand. Well, all of these numbers are going to tell me something. So this right here is the room temperature. So remember the surrounding environment. This is room temperature. That's going to be T of S or T sub S, right? So that's going to be 72. The pizza is cooked at 425 degrees Fahrenheit. So that is the initial temperature of the object. So that's T sub 0 or T sub naught. That's 425. That's the amount or the temperature of the pizza when it comes out of the oven. Okay, 425 degrees. This 2 minutes here is basically our time. 2 minutes. Okay, that's how long we're gonna have to wait, or we took the temperature the first time. And then after 2 minutes, the pizza is now 285 degrees. So that's really time. That's the temperature after a certain amount of time. So if I plug in 2 to the formula, then I should get 285, and that's good. Okay, so that gives us one kind of ordered pair, one solution there we can use to kind of figure some other stuff out. Now the question then states, I want to know how long it takes to get to 120 degrees Fahrenheit. So how long? So 120 degrees equals how much minutes? This is what I need to know. And I need to do this problem basically twice, okay? Because I have an unknown in this problem, and it's the value K. It's that material property, right? We talked about that. Depends on the material properties of the object. So basically what the object is made of will allow it to cool faster or cool not as fast. I want to find that K value. So here we go. T of S, I know, it says right here was 72. So boom, 72. Plus T sub 0, or T sub naught, is 425. Minus, well, T sub S again is 72. Then E to the negative K. We don't know K, but we do know the value of T, which is 2. And when T is 2, we know the temperature is 285 degrees. So the only thing here I do not have is that K value. That's the only unknown I don't have. So here's how we're going to solve it. I'm going to bring the 72 over. That gives me 213. Remember, I got to subtract it, right? Minus 72. Okay, equals 425 minus 72 in parentheses there. E to that negative K times 2, or negative 2K. Let me rewrite that, negative 2K there. Okay, there we go. Now I'm going to do this in parentheses right here. So 425 minus 72. So 425 minus 72 is 353, and I just kind of filled in what was left. Then I'm going to divide both sides by 353, and that will cancel out the right side. And then 213 divided by 353 is 0.603399. I'm going to go 6 decimal places here. The reason why is I want to get a more approximate answer, like a closer answer. If you only round to 3 places, then you're going to get not as exact. So I just want to make it a little more exact. Okay, and that equals E to the negative 2K. So now I have an E on the right side. I have a number on the left. Well, this is the base E. Okay, so how do I do that? I have to take a natural log. Remember, base E is natural log. So I can take the natural log of 0.603399 equals, remember when I take the natural log of the right side, those just cancel and I bring down the negative 2K. I'm going to put in my calculator ln of 0.603399 and get negative 0.505177. There we go, 6 spots, okay? 0.505177 is equal to negative 2K. Then I have to divide by the negative 2. So they're now both positive, right? So 0.505177, divide that by 2, I get K is equal to 0.2525885. I just wrote what was on my calculator. So that's what I got. I know it's 7 decimals, but that's okay. All right, so that's my K value. Whew, that's a lot of work. Well, guess what? We're going to have to do that one more time. Oh man, I don't like this problem. I'm sorry, man. You guys got to bear with me here. So what I'm going to do is I'm going to rewrite this equation right here with this is our new k, and all of these numbers except this one and this one, because now I'm going to use the 120 as the t of t. Okay, that's going to be the left-hand side. So I'm going to rewrite it here. Okay, there we go. I rewrote it. This now 120, which is what I want, and I do not know the time. That's my goal. I want to find that time. So here we go. I'm going to move that back over. So 120 minus 72 is 48 equals 425 minus 72, which was from before, 353, e to the negative 0.2525885 times t. I'm going to divide both sides by that 353, just like I did before. I'm going to plug this in my calculator and get 0.135977. Again, 6 spots. Makes it a little easier. Equals e to that power negative 0.2525885 times t. Now, again, I want to introduce the ln of both sides. So that will cancel. That will drop that. I'm going to take the ln of point all that, and I'm going to write it right there, which is negative 1.99527. It rounds pretty nice to 5 places there. Equals negative 0.2525885 t. I got to solve for t. I got to divide both sides by that. So I'm going to divide negative 1.99527 divided by this garbage right here, and I'm going to get an answer, which is t is equal to 9 minutes. And if you want to round it to the nearest minute, and if you want to write 8 minutes, that's okay as well. So he has to wait 8 minutes in order to get this pizza down to 120 degrees Fahrenheit, so it's safe to eat and not burn yourself. Okay, you don't want to be suing the pizza place because they made it too hot because you were just too impatient to wait 8 minutes. Okay, that's the time it takes to get home. All right, 8 minutes, that's the time it takes to get home. All right, that is going to conclude your 7.4 lesson. I know it's kind of long, but it's really, this problem is a long part. This problem right here, it takes a long time. If you have questions on the practice on this problem, please ask. I'll make an application video that goes with that problem as well. But you should be good to go. All right, this is Wharton saying peace. Remember, take notes, do work, and you will be successful.